This video is about synthetic division, and for a general important note, we'll begin by saying this. When dividing a polynomial by a binomial of the form x minus c for some constant c, we can use synthetic division. And this point is important because if it doesn't actually fit this description of binomial of the form x minus c that we're dividing by, then synthetic division won't even work. So though it's actually a really nice shortcut to long division, which we've done in a previous topic, synthetic division doesn't apply in every case of polynomial division. So we have to be careful to understand when it applies, and then of course when it does, we'll go ahead and use it. Let's start with an example which begins with a polynomial in parentheses, and that polynomial is x to the fifth plus 4x to the fourth minus 3x squared plus 2x plus 3, close parentheses, and we're dividing that by x minus 3. Now notice that this is a polynomial divided by binomial, and we just discussed in a previous topic long division of polynomials, which actually could work fine with this example, but we're here to try to demonstrate this other method, synthetic division, which is more convenient as long as we fit the format here. So let's understand we're dividing by x minus 3. That kind of fits our x minus c setup that we need here. Because remember, if we don't have that kind of divisor or denominator, then this process won't actually even work. So let's acknowledge that it actually does fit, but let's also acknowledge that if you remember back to when we did long division, we discussed the need to put in descending order with every power of x in descending order available. So notice that this dividend of x to the fifth plus 4x to the fourth minus 3x squared, it seems to skip over. So we could say we have need to fill in missing powers of the variable. And of course we want this in descending order. Okay, so what I mean is we're missing an x cubed term here, right? We have x to the fourth and then x squared. We're missing the x cubed, otherwise everything's in descending order. So we're going to be sure to fill that in. Now, we're going to fill it in not in the exact same way that we did with long division, because we're not going to use the exact same format of that. In synthetic division, we have to understand what our c value is. So you'll notice here, since we're dividing by x minus 3, here you could say c equals 3. That fits the x minus c format that we were expecting or hoping to find, and of course here we find it, so c is 3, x minus 3. Now with that being the case, we're going to take our c value and just tuck it up in a lonely corner. It's kind of just covered in this little, half box or so, you could say. So that's where the c value goes in the initial setup for this synthetic division. So we have it tucked away in this box in this upper left corner. But then to the right of that box, what we're going to do is write out the coefficients only of all the terms of this dividend or numerator in descending order, including any missing ones we have to fill in. Okay, so what I mean is we already have descending order of terms written that way in this dividend originally. So we're going to put the coefficients only. Well, notice x to the fifth is really a 1x to the fifth, so we put a 1 as that first leading coefficient. The next coefficient is the positive 4. We include the sign in front of a term with it, so we put a positive 4. We're not going to put a plus sign in with the 4, we're just going to put a 4, positive 4. Then after that term is where we understood there to be a missing third term, so we're going to fill in that missing one with a 0, kind of like we did in the long division process, except this time we're only using coefficients, so it's only the number 0, no variable with it. And then we continue on with the remaining coefficients, so after that we'd have a negative 3 because of the negative 3x squared, and then a positive 2 because of the plus 2x, and then a positive 3. because of that constant term at the end. Now, observe that these coefficients are written out just all in line from left to right in descending order, again with the missing one represented with the 0. And it can be a little difficult to be clear about this, but notice we're just writing them all with some space between them. Like the negative sign in front of the 3 coefficient, that's not going to be a minus, like a 0 minus 3. Notice there's enough space between all of these coefficients just to kind of see them and treat them as separate numbers. That's kind of what we want to go for here. Now, the process of synthetic division will result in the same as the long division, but it's just simpler. So we're going to take this first coefficient of 1, and to kick this process off, we're simply going to drop it straight down vertically and write it beneath this horizontal dividing bar that we've drawn here. So we have a 1 drop straight down. Then the process of synthetic division is a pattern where we will take the first, so let's use a color here. We're going to take this C value that we have written out in its own lonely box. We're going to multiply that value times the number we wrote beneath here, this 1 we dropped down, and we're going to bounce the result back up diagonally into the spot in the next space beneath now the 4. So 3 times 1 is 3. We put the 3 now beneath the 4. Then we're going to add down vertically in that column. So 4 plus 3 is 7. Okay, now you may be thinking already, like, what in the world? This is kind of a strange process. I see no pattern to this. Just give it a chance. Okay, hold on. You will eventually see how this does shortcut the entire division process, but it does take some getting used to. So, it may take more than one example, and that's fine. So we add straight down with the 4 and 3 and get the 7, and guess what? Now we do the exact same bouncing multiplication. So now we do the 3 times the 7 and bounce that result back up in the next place. So 3 times 7 is 21. That's now written beneath the 0 that we filled in. And now we add down there vertically as well. So 0 plus 21 is, well, 21. Now we bounce again. So 3 times 21 goes up now beneath the negative 3. 3 times 21 is 63. So we put that result in the next place beneath the negative 3. Add down again vertically. Negative 3 plus 63 is 60. And then do another bouncing multiplication. We just keep doing this pattern all the way through. So 3 times 60, of course, that's 180. That bounces up in the next place, now beneath the 2. Add down vertically. 2 plus 180 is 182. Bounce again. 3 times 182 now gets written up in the next and last spot, which of course is 546. That's 3 times 182. Add down vertically, and we get 549. Okay, so that's it. Now, again, that can look like a random spread of numbers by the end, but once you practice this pattern, I think you'll find it to be simply arithmetic as opposed to all of the algebraic considerations with like terms that were involved in the long division process. This gets the exact same job done in a simpler, streamlined fashion. But of course, it only applies in these certain cases as defined above. Now, you may say, well, okay, I don't see anything that looks like an answer here, so what's going on? Well, in synthetic division, the last number you get at the end of your row, at the bottom beneath this big horizontal dividing bar, this is always the remainder. So you could end up with a 0 in that spot, which of course would mean there's no remainder. But if it's something other than 0, that's your remainder. And then the way you convert what you see into an answer is you're going to take all these numbers now written beneath our horizontal dividing bar and make those coefficients of your polynomial answer, which is always going to start 1 degree less than the original dividend. So notice we started with an x to the 5th. That means our answer is going to start as x to the 4th. But it's going to be a 1x to the 4th because of the 1 as that first leading coefficient. Afterward, we see a positive 7, so we'll say plus 7, and then we just go in descending order from here. So plus 7x cubed, plus 21x squared, plus 60x. I'm just using all these coefficients as written in order. And then plus 182. And then our remainders at the end, and like we saw with remainders before, we have to attach them with a plus or minus. This is a positive 549, so we'll put a plus, and then we put 549 over, and then the original divisor. In this case, it was x minus 3. And so there we have it. That's our final result. And yes, you can check it with long division if you want, but I think you'll find that process to be much more painful. This one, when applicable, which is only in the case of dividing by an x minus c binomial, this works much easier. Let's try another example. This next one begins with a polynomial in parentheses, written as x squared minus 6x minus 6x cubed plus x to the fourth, and then we're dividing that by another polynomial in parentheses written as 6 plus x. Now we have a little housekeeping to do in this example, kind of like we did in the previous one, and that is we want to make sure and put things in descending order. We mentioned this before with long division, and here we're seeing an example of how to do it. So we need this, so I'll say put in descending order. And it has to be in descending order with all missing powers filled in order to match the setup needed for this synthetic division. So I'm actually just going to rewrite this whole thing in that way. Instead of this original polynomial you see in parentheses, let's just shuffle the terms around to be in descending order. That would give us x to the fourth minus 6x cubed plus x squared minus 6x, close parentheses. We're dividing that by, and we want the the divisor, the denominator, to also be in descending order as well. So we're going to write that as x plus 6 in matching variable descending order. Okay, now we're ready to go with the synthetic division. And notice we're dividing by an x minus c, or is it? Right, so one issue you can notice here is that if you compare this up with the way the setup is supposed to be and up in our notes, we're supposed to be dividing by x minus c, where c is some constant. Well, I don't see that, right? So how is x plus 6 really an x minus something? Or does it match? Well, it turns out it could, as long as c is the opposite. So x minus negative 6 would be the same thing as x plus 6, which means we do actually have the x minus c form that we need for synthetic division, where c is this negative 6 value. And so we can utilize long division, but notice that we have to use the opposite of the number we see, that's S-E-E-C, in the end here. So we have x plus 6, that means c is actually negative 6. So we're going to tuck negative 6 up in the corner, and then we'll proceed with the same thing we did above, which is, in descending order, write the coefficients only of our dividend. And notice we're not actually missing any powers of x here, except you may recall we had to fill in a constant in an example in long division. Notice we're missing a constant term at the end here, so we may want to fill that in. But let's notice all the coefficients in descending order are kind of staring us in the face. We have 1 in front of the x to the fourth, then a negative 6. Notice I'm just spacing these out a little bit. Then a 1 for the x squared, and then another negative 6. And then we're going to fill in that missing constant with a 0. So I'll say here, as a reminder, fill in missing terms. And the missing term here was the constant. Okay, the setup is pretty much there. We're going to put our large horizontal dividing bar, drop our first term straight down to get the process kicked off. We write a 1 beneath, and now we'll start the bouncing multiplication. Negative 6 times 1 is negative 6. Add down, we get a negative 12. Negative 6 times negative 12 would be a positive 72. Add down, we get a 73. Negative 6 times positive 73 would be a negative 438. Add down the negative 6 plus that would be a negative 444. Bounce again, negative 6 times negative 444 would be a 2,664. And then add down vertically 0 plus that gives us the 2664, which will end up being our remainder. So notice we utilize that extra 0 that we filled in order to make up for all the terms we have and get a remainder. And so now we'll go ahead and just rewrite our full answer in polynomial form using the coefficients we've now discovered in this synthetic division process. So that will result in a 1x cubed. We're going 1 degree less than the original dividend, numerator that is. So 1x cubed, then we have a minus 12x squared plus 73x minus 444. And then here's our remainder, so it's positive, so plus 2664 over the original divisor of x plus 6. And that is our final result using synthetic division. Let's try another example. This next one begins with a polynomial in parentheses, that is 2x to the fourth minus x cubed plus 2x squared minus 3x plus 1, close parentheses. And we're dividing that by x minus 1/2. So notice we fit the x minus c. In this case, c is the positive 1/2. Remember, use the opposite of what you actually view in this last term here. So really, c is a positive 1/2. We have x minus that we're dividing by here. And now we're going to copy it on the coefficients. Notice they're in descending order. No terms are missing. We even have the constant term all nicely tucked in there. So we have 2x to the fourth, which means 2 for that coefficient, then a negative 1, and a 2, negative 3, and a positive 1. Put a space and then a horizontal dividing bar. Then we'll kick things off by dropping our first coefficient directly below and then starting the bouncing multiplication. So 1/2 times 2 would be 1. Add down the next column, negative 1 plus 1 is 0. 1/2 times 0 is 0. Add down again, 2 plus 0 is 2. 1/2 times 2 is 1. Add down again, negative 3 plus 1 is negative 2. 1/2 times negative 2 is negative 1. Add down again, and 1 plus negative 1 is 0. Remember, the last term is the remainder, always, and there is no remainder in this case because that's a 0. So we'll go ahead and convert this to its polynomial form, which would be a 2 for the leading coefficient. We go 1 degree less than our original dividend, so we have 2x cubed, and then we'll say the next coefficient is 0, so we'd have a plus 0x squared. You don't have to write that one in your answer. You can just ignore it if it's 0, or if it's clearer, just write plus 0x squared. Then we'd have plus 2x using the next one, and then minus 2. And remember, no remainder for this one, so that's where we would stop. Now, within the context of intermediate algebra, you will sometimes see a topic involved in a section like this that uses something called the remainder theorem. And so if you see that in a problem or notes in the book we're using, we're going to save that topic for the next algebra course, college algebra. And in this scope, for this course, we're simply going to just get good at the synthetic division and skip over the remainder theorem for now. Again, we'll definitely pick that up in the next course. But for here, we'll stop right there.